हेलो पीपल, हाउ आर यू ऑल डूइंग? कैसे हैं आप लोग? एम आई ऑडिबल? ऑडियो वीडियो इज क्लियर? So welcome to another session for the NPCIL and BARC interview series. And here today we will be talking about the science of AC, the science, the mechanism, working principle behind the air conditioner as well as air cooler. Okay, तो यहाँ पे हमारा जो क्वेश्चन है, the most important and most common question they ask in interviews in the discussion, that is, why does an AC air conditioner make your room dry while an air cooler makes it humid? एयर कंडीशनर रूम को ड्राई और एयर कूलर रूम को ह्यूमिड बनाता है. व्हाट इज द रीजन? ओके, तो वी विल बी टॉकिंग अबाउट दिस. We will observe the working principle, we will study all the things, and if there will be any doubt, we will be addressing your doubts also. You can write your doubts in the comment page, in the section, in the live chat. And similarly, we will see some other questions also. We will try to address them, all the questions possible from this topic. So, are you guys ready? Are you guys ready? Answer in the chat. Then we will do the discussion and start. Yes. Okay. Wonderful. So now let's understand. Let's go. So why does an AC make your room dry while air cooler makes it humid? तो उसे समझने का ट्राई करते हैं. Let's try to understand this. Okay. So what happens when we talk about the air conditioner? So in air conditioner, air conditioner works on the refrigeration cycle. Okay. Air conditioner works on the refrigeration cycle. What is that? We will discuss. In thermodynamics, you must have seen Clausius' statement, second law of thermodynamics, refrigeration cycle. So I'm talking about that refrigeration cycle only. Okay. So air conditioner works on the refrigeration cycle. And when it works on the refrigeration cycle, so what happens? There is a, in refrigeration cycle, there are four components. Okay. What are the four components of the refrigeration cycle? You know that compressors, condensers, evaporators, and expansion valve. Okay. Or you can say expansion device or throttling process. So what happens in air conditioner? It takes the air from the room. It withdraws the air from the room, and then that air which it has taken from the room goes to the system, compressor, evaporator coil, and all that. And there, in the near the evaporator coil, the moisture present in the air condensed. ओके, आपने देखा होगा एसी में जो आपका मॉइस्चर निकलता है, when AC is working, so there, you know what happens. What is the input? The only input is electricity. The only input is electricity, but the output is the cooling plus the moisture, the liquid coming through the pipe. Correct? तो ये moisture कहाँ से आया? Kind of, you can say, in a certain manner, that inside the air conditioner, dehumidification of air is taking place. And dehumidification of air means removal of moisture. Correct? So that's why the humidity of air inside the room decreases. Okay, humidity in the room decreases. But if I talk about the air cooler, so in case of air cooler, you know what are the components? The water pump, the pads, and fan. Three components are there. We will look for each and everything. Don't worry, we will discuss them. So what happens? The air circulate through the pads. Air circulate in the cooler, in the chamber, and mixes with water, then enters in the room. So in this process, what happens? Due to evaporative cooling, due to evaporative cooling, the temperature of air decreases and the but the humidity of the air increases. Simple idea. This is one very simple answer. Okay. Now we will try to understand this in a more detailed perspective. Trust me, after this session, you will be able to understand that also in your room, in your house, in your bedroom. If air conditioner is there, how can you increase the cooling also without increasing the electricity load? Okay. So if let's talk about each one of these things. First, we will be talking about the air conditioner. Okay. So air conditioner, the working principle. The working principle of air conditioner is refrigeration cycle. Air conditioners work on the refrigeration cycle, and refrigeration cycle is there. So obviously you can understand four components has to be there. Eh, for heat addition, heat rejection, compression, and expansion. Okay. In case any one of you have no idea. So I will go slightly in thermodynamics. And in thermodynamics, you know, there is a second law of thermodynamics. And in second law of thermodynamics, there is a statement known as Clausius statement. Okay, we have discussed this so many times in so many sessions in the classes itself. So we will not go in much detail and basic fundamentals. I will just give you the overview of the Clausius statement here. But still, if you find any difficulty or doubt, you can ask. in the chat. Okay. So what is Clausius statement? You know, Clausius statement says it is impossible to construct a thermodynamic device that can transfer the heat. Sorry, properly लिख लेता हूँ. It is impossible to construct a thermodynamic device operating in a thermodynamic cycle and transfer the heat from low temperature region to high temperature region without producing any other effect. ओके, मतलब इनका कहने का था कि अगर मेरे पास सपोज एक हाई टेम्परेचर रिजर्वायर है, एक लो टेम्परेचर रिजर्वायर है, एंड यू नो इफ दे आर इन कॉन्टेक्ट, so heat transfer will occur from high temperature body to low temperature body naturally. That will be a spontaneous process. But if you want to do the opposite, if you want to transfer the heat from low to high, then it will not be spontaneous. It will be non-spontaneous process. And if it is a non-spontaneous process, so here you cannot construct a machine, you cannot use a machine which can directly do that without any other effect. Okay. So here, what is the meaning of without any other effect? The meaning is work. On the machine, we need to do the work. Only then it is possible. Correct? Only then it is possible. Okay. So how it is possible, that we will see. So we will, you know that suppose there is a high temperature reservoir. There is a low temperature reservoir. Let's say temperature of low temperature reservoir is temperature TL, high temperature reservoir is temperature TH. Okay. For better understanding, let's give some values, random values. Let's say the low temperature body at 4 degrees Celsius and high temperature body is at 40 degrees Celsius. Suppose. Okay. So what I need to do? So here first I will use a device, a piece of component, let's say evaporator. And in the evaporator, I will send a liquid, let's say a saturated liquid I am sending, suppose at temperature minus 10 degrees Celsius. So when this evaporator will be in contact with the low temperature device, low temperature region, then you can understand naturally heat transfer will start, let's say QL, from low temperature body, from a high temperature body relatively 4 to low temperature liquid at minus 10. So this liquid will absorb this heat and gets vaporized. It will become the saturated vapors at the same temperature. Okay. Now, similarly for the high temperature body, here suppose I am using a device, a component, let's say condenser. So the idea is in the condenser, I should send our vapors, high temperature vapors, which should have the temperature above 40. So let's say the temperature of these vapor is about 60 degrees Celsius. So when these vapors will come in contact with the high temperature body, so they will transfer the heat because relatively the temperature of vapors is higher than the TH. And let's say this heat transfer is QH. So vapor will loses their latent heat and they will get condensed. And this condensate will be leaving at 60 degrees Celsius. Correct? This is the whole idea. Now here, what I will do, my purpose is to increase the temperature of this vapors from minus 10 to 60. How can I do that? How can I do that? So I can use a compressor. So in this compressor, I will send this saturated vapor at minus 10 degrees Celsius. And then these vapors will enter in the compressor, get compressed. And for compression, I need to supply some work, let's say W. Now, the vapors will get compressed, so their pressure will increase. And as the pressure increases, their temperature will also increase. You know that. Okay. So we can say these are now high pressure vapors, and these are basically the low pressure vapors, which enters and compressed, and high pressure vapor releases. So pressure increases, temperature also increases. And now this saturated liquid is at 60 degrees Celsius. I need to bring down its temperature up to minus 10. So what I need? I need to remove the temperature, decrease the temperature. So I can use a throttling valve. A throttling process I will use. So here the temperature of this liquid, because when the liquid will passes it through the throttling process, you know, pressure will decrease. They will undergo the sudden expansion. Because of that, if Joule-Thomson coefficient is positive, cooling will occur. Correct. So they ask here, what should be the Joule-Thomson coefficient? So it should be positive. So pressure will decrease and cooling will occur. Cooling will occur, so temperature will also decrease. And if temperature decreases, so it is also possible that some of the liquid may get vaporized. So here, ultimately, in practical scenarios, along with the saturated liquid, we might have some saturated vapors also. So a mixture of liquid and vapors enters the evaporator. So this whole thing you can see the heat transfer from low temperature body to high temperature body, QL to QH, is possible, but only when some work is done on the system, when some extra effect is done. Okay, without doing this work, you cannot increase this temperature. So this whole system, this whole thing is what we call refrigeration cycle. And these are the four components of the refrigeration cycle. This is what you have studied in thermodynamics, and this is the refrigeration cycle we use in air conditioner also. I hope it is clear what is the refrigeration cycle and how it happens. That's why they say, मैं एक bonus question आपको बोला हमने पहले भी बात की थी but फिर भी बता रहा हूँ. If you open the door of refrigerator, if door of refrigerator is open for longer duration, for long time, then temperature of room will increase. Correct? What is the whole idea? The whole idea is, see, QL is coming from the low temperature body through the refrigerator. You know all this machine and all. Some work is done. And QH is rejected to the high temperature body. So in case of refrigerators, the food items, the beverages, and all those things present in the refrigerator are the low temperature reason, because we want to keep the temperature inside the refrigerator as low as possible. Okay, to preserve the food and all those items. Okay, now suppose this heat it took from the food and beverages is about 20 watt. Correct? Work done on the system on the refrigerator is, let's say, 40 watt. So you can understand high temperature region is the ambient air, the room air. So it will reject, you can see 40 plus 20, 60 watt of heat. Because from first law of thermodynamics, you know that QH is equal to QL plus W here. Okay. Now understand the logic. If you open the door of refrigerator, then the QL will increase because now refrigerator will initially it was extracting the heat from the food items. Now this refrigerator will extract the heat from the room air also. Excuse me. Okay. So suppose now it is extracting some 10-watt heat extra from the air. So think like this. It extracted 10 watt of air from the room. Okay. But now eventually how much heat it will supply to the room? 60 plus 10, 70 watt. तो remove तो 10 किया था air से. But supply कितना किया? Add कितना किया? 70. Remove 10 watt heat, but added 70 watt. So ultimately the net temperature of the room will increase. This is the reason. That's how you can explain. Okay. तो वापस आते हैं अपने टॉपिक पर, which is the air conditioner. This is what I have written, the refrigeration cycle. ठीक है. In simple words, I have explained it is impossible for a system to transfer the heat from colder body to hotter body without any external work. This leads to the idea of refrigerator, a device that removes heat from a low temperature body and rejects it to the high temperature reservoir. ठीक है. अब आप बोलोगे सर हीट पंप में भी तो यही होता है. Yes, heat pump is also the same thing, but the idea is the objective is different. In case of heat pump, the ob- the objective is to add the heat to a hot temperature body, hotter body, by taking heat from low temperature body or a colder body, you can say. Okay. While if I talk about the refrigerator, what is happening in refrigerator? The purpose is to remove heat from colder body by rejecting it to hotter body. ओके. इट इज द ऑब्जेक्टिव कि रेफ्रिजरेटर में हम ठंडी जगह को और ठंडा करना चाहते हैं, हीट पंप में गर्म जगह को और गर्म करना चाहते हैं. लाइक इन विंटर्स यू वांट द रूम टेम्परेचर ऑफ रूम योर हाउस टू स्टे हायर एज कंपेयर टू आउटसाइड एयर. और रेफ्रिजरेटर में हम ठंडी जगह को ठंडा करना चाहते हैं, मीन्स वी वांट द टेम्परेचर ऑफ द रेफ्रिजरेटर दोज फूड आइटम्स टू ले स्टे लो. ठीक है. तो दिस इज द पर्पस. mechanism is same but the purpose is different. Okay. So in this cycle, when we talk about the ideal refrigeration cycle, what happens? Isentropic compression happens. Okay, as I have explained, just give me a second. Let me simplify this for you. Here, see, ideally here, no heat loss in the compressor, perfectly insulated. No heat loss here, perfectly insulated. So this is what I said. And you know that reversible adiabatic process is also known as isentropic process. Reversible adiabatic process, also known as isentropic process, because entropy change will be zero. Correct. But आप ये मत बोलना कि सभी adiabatic process होती है. No, again I am clearing this thing. While if you see irreversible adiabatic process, there also no heat exchange between system and surrounding, but still in this case entropy change is positive. ठीक है, irreversible adiabatic process में entropy change जो है positive होता है. Okay, वहां पे although there is no heat exchange between system and surrounding, means Q12 is 0 in both the places, but still there is a entropy rise in irreversible. तो उसे isentropic नहीं बोलते, isentropic बोला है तो it is obvious reversible adiabatic है. Why? Because in irreversible, due to friction, heat generation will occur that will cause the rise in entropy. Isobaric heat rejection in condenser, as you have seen, constant pressure, heat rejection is there. Pressure is constant and heat is being rejected. Similarly here, constant pressure, heat addition. Okay. And then isenthalpic expansion. Throttling valve, how they work, throttling process. They are what we call isenthalpic process because enthalpy remain constant. Okay. And isobaric heat addition in evaporator. And here in an ideal cycle, we generally use these to understand the concept of COP, coefficient of performances, entropy changes, and efficiency. Isentropic efficiencies are and all, which are also called second law efficiencies. Okay. This happens in the ideal scenario. But अगर practical बात करें in real scenario, what happens? The same refrigeration cycles are used. Okay. And refrigeration cycles are also known as vapor compression cycles. ठीक है, because ultimately vapors are getting compressed. वो आप लोग देख चुके हो. See, compressor, these vapors are getting compressed. And यहाँ पे जो हमारा focus होता है, air conditioners, refrigerator, chillers में हम use करते हैं, and the focus is the performance of cooling coil, basically the evaporators, the refrigerant types. Refrigerant means this liquid which we are using. You can understand the temperature of this liquid has to be, the boiling point temperature of this liquid has to be lower than the temperature of colder body 4. तभी तो ये सब होगा. You cannot use water here because the temperature, boiling point temperature of water is 100. So water cannot take the heat from this. So that only that liquid can take the heat which has low boiling point temperature and vaporize. Okay. So this type of liquids in refrigerator are known as refrigerants. इन एयर कंडीशनर्स, जो आपने रेफ्रिजरेटर होते हैं, एयर कंडीशनर तो बोलते हैं ना गैस खत्म हो गई, तो बेसिकली वो गैस का क्या मतलब है, रेफ्रिजरेंट. और वो उसे गैस क्यों बोल रहे हैं? क्योंकि एट नॉर्मल टेम्परेचर boiling point temperature is low. At normal temperature pressure, those refrigerants will be in the gaseous state. That's why those people say gas. ठीक है. और यहाँ पे हमारा जो हीट लोड है, रूम कंडीशन है, साइक्रोमेट्री, बेसिकली ह्यूमिडिटी एंड ऑल, उन सब पे फोकस ज्यादा होता है. ठीक है, क्योंकि ह्यूमिडिटी, because in air conditioners, cooling is taking place, but humidity is also decreasing. So the focus is कि humidity should not decrease below the comfort level. क्योंकि बहुत ज्यादा अगर chilled, dry environment हो गया, you know, low humidity is not suitable for us for proper living, for comfortable life, comfortable living. Humidity should be there. A sufficient humidity should be there, and you guys already know what it should be. Okay, so here this is the main focus, that it should not decrease a very large amount of humidity. Now, if I talk about the ideal cycle and real cycles, what is the difference? So I have created this table to summarize all the points. Okay, so you can understand here. Purpose in ideal cycle, theoretical cycle purpose is to explain the second law, COP, ideal cycle, etc. And in real applications, the purpose is cooling and humidity control. Okay? Like I said, humidity should not decrease very up to a very low value. The cycle is same, vapor compression is taking place. Working fluid here is the theoretical fluid. It is the ideal fluid, we say, ideal refrigerant. But in general, in real refrigerators, AC, the fluid is used is R22, R410A, R134A, etc. You know all those things. Okay, so heat source and sink, thermal reservoir, here indoor and outdoor air. वहां पे तो हम थर्मल रिजर्वायर का कॉन्सेप्ट बोलते हैं, हाई टेम्परेचर रिजर्वायर, लो टेम्परेचर रिजर्वायर. But here it is in air conditioner. It is the air inside the room is low temperature reservoir and air outside the room is high temperature reservoir. Because summer में ही तो आप AC use करते हो. When the temperature of outside air is more and you want the temperature of indoor air to stay low. Okay, these are the considerations and modeling. ठीक है, ये आपके रेफ्रिजरेशन साइकिल हो गई इन सिंपल टर्म्स. अगर आपको देखना है तो एक्सप्लेन करना है, यू कैन सी. Low pressure vapors enter the compressor, converts into high pressure vapors. Then these high pressure vapors enters in the condenser where the heat is rejected, QH. And then this saturated liquid, high pressure liquid enters in the throttling valve where temperature decreases, pressure decreases. So low pressure liquid or vapor mixture, I told you, it could be a mixture of liquid and vapor as well in reality. So this low pressure vapor and liquid mixture enters in the evaporator where it takes the heat QL from the indoor air and rejects it to the outdoor air. तो आप लोगों ने जो स्प्लिट एसी या विंडो एसी देखे होंगे तो उनके बाहर पीछे की साइड अगर आप देखो और गर्म लगता है क्योंकि वो सारी गर्म हवा बाहर सप्लाई हो रही है, आउटडोर एयर को सप्लाई हो रही है. ओके, एंड इनसाइड द रूम you receive cooled air. Basically, it replaces the air, you can say. It takes the, in AC, if you have seen AC, there are two compartments. From one compartment, they take the air from the room. Then that air passes through all this thing, get cooled, and then the cooled air return back to the indoor room, indoor air by the second compartment. That's how the AC works. Okay. So this is the basic working. What happens in the compressor and all these things I have told you. Compressor, it compresses the refrigerant, high pressure, high temperature. Condenser transfer the heat to surroundings. Refrigerant condenses, and that condensed refrigerant enters in the expansion valve throttling process where pressure decreases and low temperature refrigerant we obtain. And then this low temperature refrigerant enters in the evaporator coil where it absorbs the heat from the air, indoor air. Okay, to keep it cool. That's how the things happen. एक बार अगर मैं आपको कंपोनेंट्स दिखाना चाहूँ तो वो भी मैं आपको दिखा देता हूँ. Just give me a second. See, this is the condenser. It looks something like this in the air conditioner. This is the evaporator. It looks like this. The evaporator coils in the refrigerator. Sorry, in the air conditioner. And this is the expansion valve. Something like this in the air conditioner. So जब भी if you have seen the servicing of AC or something, यहाँ आप अगर ओपन करके देखोगे तो आपको ये सारे कंपोनेंट्स उसमें क्लियरली विजिबल होंगे. Okay. Now, concept of psychrometry. तो जो साइकोमेट्री है, हाउ एयर कंडीशनर वर्क्स ऑन साइकोमेट्री, व्हाट आर द कॉन्सेप्ट्स, टर्मिनोलॉजीज वी यूज. तो you guys, we have in the previous session, I have taken already one session on humidification and dehumidification. So there I have explained all these terminologies. So you can check that session also. I will ask the team to uh, add the link of that session in this video description as well. Okay. So air is not dry; it contains moisture as well. So dry bulb temperature concept, wet bulb temperature concept, relative humidity. And again, thank you guys, because after the previous session I received the messages from many students कि सर आपने जो वेट बल्ब टेम्परेचर का कॉन्सेप्ट एक्सप्लेन किया था बहुत अच्छे से समझ में आया. तो थैंक यू गाइस. आप लोग अपना फीडबैक ऐसे ही शेयर कर सकते हो, बट अच्छा लगेगा अगर आप ग्रुप्स पे मैसेजेस करने की जगह, पर्सनल मैसेजेस करने की जगह, अगर कमेंट बॉक्स में लिखो. तो इससे आपके बाकी फ्रेंड्स को भी हेल्प मिलेगी, वीडियो को भी रीच मिलेगी, ताकि और ज्यादा स्टूडेंट्स को हेल्प मिले. ओके, दैट इज द होल पर्पस. दैट इज द पर्पस. दैट इज द रीजन आई केम ऑन द अनअकैडमी, to reach as many students, to help them. ठीक है. And one fourth component is sensible heat factor. Sensible heat factor क्या होता है? SHF. It is the ratio of sensible heat divided by sensible heat plus latent heat. Correct. अब हमारे पास क्या होते हैं? टूल्स होते हैं, ठीक है, जिससे हम एयर प्रॉपर्टी के जो चेंजेस हो रहे हैं उन्हें ट्रैक कर सकते हैं. You guys know, like thermometer, we have to measure the temperature. Similarly, there are many tools. There are devices also with to directly check the humidity as well. You guys know that. Okay, so मेरा question है, what is the which instrument is used to measure the humidity? Can you name? ह्यूमिडिटी चेक करने के लिए कौन सा इक्विपमेंट यूज करते हैं? सर, एक्सप्लेन द एक्सपेंशन वॉल्व थ्रॉटलिंग प्रोसेस. ओके, आई विल. लेट मी कंप्लीट दिस डिस्कशन. ठीक है. अब एसी जो क्वाइ एयर कंडीशनर है, साइक्रोमेट्रिक चार्ट आप लोगों ने देखा होगा. ठीक है. अभी हमारा जो एनपीसीआई बार्क एंड मॉक इंटरव्यू सेशन चल रहे हैं, वहां पे भी मैंने डिस्कशन किया था एक स्टूडेंट के साथ इसके ऊपर. जस्ट गिव मी अ सेकंड. तो आपका जो साइकोमेट्रिक चार्ट है, इट लुक्स समथिंग लाइक दिस, वेयर वी हैव द 7 components: ड्राई बल्ब टेम्परेचर, ड्यू पॉइंट टेम्परेचर, वेट बल्ब टेम्परेचर, ह्यूमिड हीट, सॉरी ह्यूमिड हीट नहीं, ह्यूमिड वॉल्यूम, एब्सोल्यूट ह्यूमिडिटी, relative humidity, and enthalpy. These are the 7 components we use in psychrometric chart. 7 parameters. तो यहाँ मेरा क्वेश्चन ये है, द क्वेश्चन इज, सपोज ऑन साइकोमेट्रिक चार्ट, inside the room, before switching on the AC, let's say the air is at this point. Let's say point A. ये मेरा point A है. ठीक है. एयर का ह्यूमिडिटी इतना है, रिलेटिव ह्यूमिडिटी इतना है, ड्राई बल्ब टेम्परेचर इतना है. ओके. नाउ when air conditioner starts, when you switch on the air conditioner, then how this point will shift, where we will be having the end point B. Where will be the end point be? So you know that in air conditioner, what is happening? In air conditioner, I have explained everything till now to you. The temperature of air is decreasing. Basically, the dry bulb temperature. So dry bulb temperature decreases, so it is obvious it has to move on the left side. Correct. Then here, dehumidification is also taking place. So that means humidity will also decrease. I'm not talking about the relative humidity. I'm talking about the absolute humidity. Because relative humidity depends on the vapor pressure as well. So if dry bulb temperature decreases, vapor pressure will also decrease. So all that stuff. I'm not going in all that. And absolute humidity decreases, तो partial pressure also decreases. ठीक है? तो अभी हम relative humidity की बात ही नहीं कर रहे हैं. Absolute humidity की बात कर रहे हैं. तो it will decrease, move downward. Correct? So point B will be somewhere on this side. That's how the point will shift on the psychrometric chart in air conditioner. Correct? Bottom left. Or you can say in which direction? Southeast, southwest, you can say. ठीक है? अगर आपको डायरेक्शंस का अच्छा आइडिया है तो आपको पता है दिस इज नॉर्थ, साउथ, ईस्ट, वेस्ट. So we can say it will move slightly on the southwest side. Correct? Are we clear? Hello? ठीक है. अब इसी में एक और क्वेश्चन आता है. ठीक है, वो थोड़ा अलग है. Not related to the type set topic which we are discussing today, but in general I am asking, where will the point shift if it is a case of adiabatic cooling? Suppose if adiabatic cooling takes place, then how the point will shift on psychrometric chart? Suppose this is the point A. If adiabatic cooling is there, then where will be the point B? So you guys can understand adiabatic cooling means the temperature of air is decreasing. So obviously it has to move on the left side. Correct? But due to adiabatic cooling, humidity of air will increase. Like you must have seen the concept of adiabatic saturation temperature. Okay, so I'm not talking about the saturation temperature, the cooling till adiabatic saturation. No, I'm just talking in a adiabatic chamber. If we have some adiabatic chamber, suppose something like this, and here air enters, and here air will leave. Inside this, it is in contact with the water. Water is sprayed over this air. So what will happen? Due to the adiabatic conditions, temperature will decrease, that is obvious, but humidity will increase. Correct? So this point will move towards the left, or you can say uh, northwest. Slightly like this. Correct? Depending on the contact, how much moisture you have added. And what will happen to the relative humidity and wet bulb temperature, all these things. I hope you guys already understand that. Okay. Otherwise, just let me know, I will explain. ठीक है. तो साइकोमेट्री अपने आप में एक बहुत बड़ा टॉपिक है, you guys know. There are many discussions they can do: adiabatic cooling, isothermal cooling, adiabatic heating, etc., adiabatic saturation temperature, wet bulb temperature, all that no stuff. Okay, so will not discuss this. So in case of air conditioner, if you have to check about the enthalpy or power calculation and all, so you can calculate like this. You know, simple. Air inside the room is getting cooled, so this will be the enthalpy change. And how much air is getting cooled per unit time? That is the mass flow rate. So based on that, you can calculate the cooling load of the air conditioner. And with the help of cooling load, you will get the idea how much power you need to supply. In ideal scenario, the power supply should be equal to the heat cooling load. Are you understanding this? Correct. So that's how you can do those calculations. So and far better cooling means higher. There should be a uh, higher drop in the enthalpy, as they said. Higher enthalpy drop means more effective cooling. Correct. Simple logic. Now, if we compare the things between the closed room and open room, बोलते हैं ना अगर आपने घर में एसी लगाया in your room तो close the door, don't open the door. What will happen if you are running the AC with open door? पूरे घर को ठंडा करना है हमें एक एसी से, एक कमरा नहीं। हमें एक एसी एक कमरे में लगा और उससे हम पूरे घर को ठंडा करना चाहते हैं। कैसे करेंगे? ज्यादा बिजली का बिल पे करके, क्योंकि कंप्रेसर लोड विल इंक्रीज। Okay, because in closed room we have fixed volume of air to circulate, but in open room, large amount of air will come. The volume of air from the room plus volume of air from outside the room. So if more and more air will enter in the air conditioner, then the compressor load will increase because large amount of heat will be has to be removed in the condenser, in the evaporator. Are you understanding? We discussed the cycle now. अगर आपका ज्यादा एयर कब आ रहा है, if more and more air is coming, so the more amount of QL will be absorbed by the refrigerant, and if more heat is absorbed by the refrigerant, so ultimately that refrigerant is going in the compressor. ठीक है? So what will happen? Compressor load will increase. So that's why the work required will also increase. Basically, the electricity consumption will increase. Okay, so this is something about the air conditioner, guys. I hope you got the whole idea. There are other points also which you can check. Okay. Now, if I talk about the refrigeration cycle, so they can ask where we use the refrigeration cycle in real life. So these are the real life applications. Generally, we use refrigeration cycle in these 8 places: in the refrigerators, freezers, air conditioners, data center cooling systems. Data centers where they have large amount of storage, CPU storages. So if CPU storages they are working continuously, so they produce such a large amount of heat. And if heat increases, आपके लैपटॉप को भी अगर गर्म हो गया, मोबाइल भी अगर गर्म हो गया, तो वो स्लो हो जाता है. You know that functioning becomes slow. तो कूलिंग के लिए वहां पे, इसके अलावा इंडस्ट्रियल चिलर्स जो होते हैं, प्रोसेस कूलिंग सिस्टम्स, like in industries. Otherwise, HVAC systems are also there in hotels, in some auditoriums. Aquarium chillers जो होते हैं, ice machines. So many places we use these refrigeration cycles. So these are just some 8. You can find many. Okay. This is the refrigeration cycle. I have already explained to you how the things are happening. Now, generally, the refrigeration cycles there are 4 types of refrigeration cycles. One is vapor compression cycle, which I just explained to you, where vapor is getting compressed. Apart from that, there is one vapor absorption cycle. ठीक है? Vapor absorption cycle is where we split the coolant into two separate bodies. One is introduced in the evaporative cooling and the other is used to absorb it. Where we use all these, I will tell you, don't worry. Apart from that, one is liquefaction, where the cooling refrigerant we are using till now, when it becomes liquid, so it is easy to store. We liquefy the refrigerant. It is generally used in industries, not in for the consumers, like AC, refrigerator, वहाँ पे use नहीं होता. इंडस्ट्री में यूज होते हैं लाइक इंडस्ट्री चिलर्स एंड ऑल वहां पे. ठीक है. एंड लास्ट इज इवेपोरेटिव रेफ्रिजरेशन साइकिल. ओके. तो क्या होता है, देखो मैंने आपको एक मेथड मेंशन कर दी है. द कंपैरिजन, वन लाइन कंपैरिजन इन ऑल दोस. Vapor compression cycle, as we have discussed, this is highly efficient and most reliable and used by by us in air conditioner rates, commercially used also, you can say. Absorption refrigeration cycle we use in those areas where the electricity is a problem. Okay, like electricity. If electricity is not there, how will you do the work on the system? Compressor कैसे run करेगा? Correct. So there we use absorption heating cycle, refrigeration cycles when the electricity is a problem. Liquefaction refrigeration cycle we use in those scenarios when extremely low temperatures required, like cryogenic processes are there. Okay, where we need to reduce the temperature of gases, or we need to convert the gases up to a liquefaction point. You guys know already gasification point, liquefaction point, thermodynamics. And evaporative refrigeration cycle we use for water evaporation to cool air. Okay, it is low maintenance cooling system, basically like cooling towers and all, air coolers. ठीक है. अब एयर कूलर्स की बात कर रहे हैं तो these are that's how air coolers work. In your home also, I hope you have seen a structure is there where at one end we connect the fan. Okay, suppose this is the room, this is outside. So air will enter from here. Inside this we have a water pump near the gates. Here we have those pads. I hope you have seen those pads where we circulate the water and water spray. So what happens? Comes in contact with this water, evaporative cooling takes place, and thus this cold air enters into the room. Now I hope you guys know the concept of evaporative cooling. And here the only electricity will be required to run this pump. Correct? What is evaporative cooling? I hope you guys have the idea. I have explained that in many sessions. Let me discuss this again here. Suppose this is the water at temperature T. And suppose here some it is open to atmosphere or maybe closed, doesn't matter. Let's say this is unsaturated air is passing. If unsaturated air is there, so what will happen. What is the scenario? So in this case, the partial pressure of moisture, let's say moisture means A, will be less than its vapor pressure. Vapor pressure of water in the liquid will be more than the partial pressure of moisture in the air. So because of that, what will happen? You know, the molecules in the liquid will try to go into the air. They will try to diffuse, concentration difference is there. So molecules will move from high concentration region to low concentration region. Now you guys understand which molecules have the higher probability to escape the liquid phase. The molecules present at the surface or the molecules present in the bulk? Surface molecules have the higher probability. Correct. In case of air conditioner, humidity decreases. We have discussed that. Correct, Sapna? And in case of air coolers, as you can understand, moisture will be carried by the air. This air is coming in contact with water. So this wet air, you can say moist air, will enter the room. So ultimately the humidity of air will increase. Okay. So here, now these surface molecules, you understand, they will escape. They will try to diffuse into the air. But can they do, now understand, can they go in the air? Can they diffuse in air directly? No. Because आपने पढ़ा होगा, आपने पढ़ा होगा ना, डिफ्यूजन क्या होता है? Diffusion is transport of molecules from a region of high concentration to a region of low concentration. Where? Within the same phase. Within the same phase, or you can say medium. है ना? यही पढ़ा है. So tell me, can these water molecules diffuse in air? Can they go into the air? No, because they are in liquid state. Air is gas state. So what will happen? First, you know, water molecules at the surface will vaporize. And when they will vaporize, after that, they will move. Those vapor molecules will move in air. Correct? Now, understand, if these molecules are vaporizing, so what they need? They need latent heat of vaporization. Latent heat is required for vaporization. So from where they will get the latent heat? From where they will get the latent heat? Are we supplying any heat here? No. So these molecules at the surface require the latent heat. So they will take this latent heat, they will absorb the latent heat from the liquid bulk. Correct? From liquid bulk. So because of this, the temperature of liquid decreases, means cooling occurs. Now you can see the evaporation is taking place and cooling is taking place. So this is what evaporative cooling. Correct? That is the whole idea of evaporative cooling. And this is the same thing we studied in wet bulb temperature. है ना? Because if this is a liquid film, so the temperature difference, the thermal equilibrium between air and liquid film will decrease. Sorry, will disturb. So if the temperature of liquid film decreases, because the surface molecules of liquid film are getting vaporized, so temperature of liquid bulk decreases, and temperature of liquid bulk decreases. यही पढ़ा था ना हमने वेट बल्ब टेम्परेचर में. This is the wet bulb which is covered with the wet cloth. Here we have the air film in contact with this moisture. So as the molecules are getting vaporized, the temperature of the liquid is decreasing here. And if temperature of liquid decreasing, then the thermal equilibrium between air film and liquid disturb. So the heat transfer will occur after this from air film to this liquid. So ultimately the temperature of air film decreases, and this is noted by the thermometer. ये dry bulb temperature था, तो अब ये यहाँ पे आ जाएगा WBT. That's why WBT is smaller than the dry bulb temperature, and it is a steady state temperature, not equilibrium. Why? Because this temperature with respect to time will not change. But it is not equilibrium temperature because at this point air film is saturated, not the air bulk. If air bulk gets saturated, then it will be the dew point temperature. Correct? I hope you remember all that we discussed in the session of humidity. Okay, so this is the concept of evaporative cooling, guys. Okay, and if all this happens in an adiabatic chamber, so ultimately what will happen? You know, air is in contact, air bulk is in contact with the liquid bulk. Since the temperature of liquid bulk decreases, so the heat transfer will start from air to liquid. So ultimately, air is losing the heat. So ultimately, sensible heat of the air is decreasing. Ultimately the temperature of the air will decrease. That's why the in adiabatic chamber, air coming out will be at lower temperature. Are you understanding this? That's how the things happen. That's why we said adiabatic cooling, temperature of air decreases. See, all the things are interrelated. So I hope this concept of evaporative cooling, air cooler is clear to everyone. Okay, अब आगे बढ़ते हैं. Working principle, I have explained this to you. Okay, here one more thing is term, evapolar. Evapolar coolers. What is evapolars? One is air conditioner, one is air cooler, one is evapolar. So you should know all these things. Check कर लेना. अब वो सब डिटेल में नहीं जा रहे अभी because that is not the part of this session. The principle of evaporative cooling I have told you. As water is evaporated, energy is lost from the air because temperature of liquid bulk is decreasing. So this is evaporative cooling. And since temperature of liquid bulk decreases, so it will ask the air कि भाई मुझे heat दे दो, मैं तो घाटे में चला गया. Then air will give the heat to the liquid bulk. So ultimately air will be in the loss. ये मैंने explain भी किया था. What surface molecules is us. Liquid bulk is our mother. Air is our father. हमने अपनी मम्मी से हमें पैसे चाहिए, पापा से तो मांगेंगे नहीं. हमने अपनी मम्मी से कहा मम्मी हमें पैसे दे दो, 100 रुपए, 500 रुपए, 1000 रुपए, जितने भी चाहिए. मम्मी ने हमें दे दिए. अब मम्मी मम्मी है, आपको पता है मम्मी को सेविंग करना पसंद है. मम्मी अपने पास पैसे कम होते हुए देख नहीं सकती. उन्होंने आपको दे तो दिए, पर जितने उन्होंने आपको दिए उतने ही वो आपके फादर से वापस ले लेंगे किसी ना किसी तरह से. तो अल्टीमेटली कौन लॉस में हुआ? लिक्विड बल्क लॉस में नहीं है. अल्टीमेटली हु इज इन लॉस? फादर. क्योंकि मम्मी ने जितने आपको दिए पैसे उतने उन्होंने फादर से वापस ले लिए, तो वो तो बैलेंस हो गई. बट फादर लॉस में रहे, मतलब ये दैट इज हाउ इट हैपेंस. ठीक है. See how these things happens. These are the evaporative pits where water distributes and all. You know all that stuff. Now the difference between air coolers, evaporative air coolers, and air conditioners. So this is a table which you can see. Evaporative air coolers produces 100% fresh air. Air conditioner recirculate the same air inside the room. मतलब रूम के अंदर जो एयर थी उसी को रिसर्कुलेट करके ठंडा करके डिह्यूमिडिफाई करके वापस भेज दिया. ठीक है. दैट इज द डिफरेंस. ये पूछा था एयर कंडीशनिंग बोल रहे हैं और एयर कूलिंग बोल रहे हैं. डिफरेंस क्या है? एयर कूलर में सिर्फ एयर ठंडी हो रही है, only the temperature is decreasing. And on the other hand, humidity is also increasing. But in case of air conditioner, conditioning कर रहे हैं हम. Conditioning means we are controlling the humidity here also. Controlling the humidity means हम humidity को comfortable level पे ला रहे हैं. So that along with the cold air, you can enjoy the comfortable humidity also as well. So this is what conditioning. जैसे आप करते हो ना हेयर कंडीशनर क्या करता है बालों के साथ? वन इज शैम्पू, एंड आफ्टर शैम्पू यू यूज हेयर कंडीशनर ऑल्सो. जो बॉयज हैं वो शायद ना समझ पाए, बट गर्ल्स अच्छे से समझती हैं. ठीक है, क्योंकि बॉयज को केयर नहीं होती अपने बालों की इतनी, जिन्हें होती है वो समझ सकते हैं. आई एम नॉट बीइंग आई एम नॉट डूइंग जेंडर डिस्क्रिमिनेशन, बट जस्ट गिविंग यू द फैक्ट. ओके, यू आर इंजीनियर्स, so you understand. No harsh feelings. So this is why it is air conditioning. ये भी आपको समझ में आना चाहिए. ये भी एक क्वेश्चन पूछा जाता है. What is the difference in air cooling and air conditioning? Understood? I hope it is clear. ठीक है. यहाँ पे विंडो ओपन रखी जाती है, बट यहाँ पे उन्हें क्लोज करना पड़ता है, डोर्स को, विंडोज को, एंड ऑल दीज थिंग्स यू कैन चेक. यहाँ पे रनिंग कॉस्ट हाई है, यहाँ पे रनिंग कॉस्ट कम है. ऑलमोस्ट 80% लेस देन द रनिंग कॉस्ट ऑफ एयर कंडीशनर्स. ठीक है. प्रैक्टिकल सिनेरियोस, कब हमें एयर कूलर यूज करना चाहिए, कब एयर कंडीशनर यूज करना चाहिए. ठीक है. Ideally, see, air conditioner you should use if you live in a humid areas like Mumbai, Chennai, coastal areas are there, Kolkata, etc. So you know humid areas means air cooler use करोगे तो और ज़्यादा humidity बढ़ जाएगी, which will be difficult for the living. So it's better to use air conditioner there. ठीक है. और otherwise if you need a proper temperature control, कि how much temperature you want in the room, 22, 18, 16, 24 what. ओके. और सबसे इंपॉर्टेंट, अगर आप अफोर्ड कर सकते हो, इफ यू कैन अफोर्ड दैट. ठीक है. नेक्स्ट, एयर कूलर. तो अगर आप किसी ड्राई एरियाज में, हॉट एरियाज में रहते हो लाइक राजस्थान, दिल्ली समर्स एक्सेट्रा, तो इंस्टेड ऑफ एयर कंडीशनर यू कैन यूज एयर कूलर्स, बिकॉज ड्राई एरिया मीन्स लो ह्यूमिडिटी इज ऑल्सो not good for survival, for comfortable living. So air coolers are better. अगर आपको लो कॉस्ट इको फ्रेंडली कूलिंग चाहिए. ठीक है. आपने देखा हो ना, जितने भी लोग अचानक से सोशल मीडिया पे आके बड़ हो जाते हैं, हम एनवायरमेंटल के दोस्त हैं, उनके घरों में आप चेक करो जाके क्या एसी यूज हो रहा है या एयर कूलर. अगर एयर कूलर यूज हो रहा है तो आप उन्हें फॉलो कर लेना कि हाँ ये सच में एनवायरमेंट के दोस्त हैं, ग्लोबल वार्मिंग के अगेंस्ट हैं. बट अगर वो ऐसे कैंपेन चला रहे हैं एसी रूम्स में बैठकर, फिर ऐसे लोगों की बात सुनने का कोई फायदा नहीं, बिकॉज ये सब दोगलापन है, जैसे अश्नीर जी बोलते हैं हमारे. ठीक है. मैं किसी को रोस्ट नहीं कर रहा हूँ, मैंने किसी ग्रेटा जी का नाम नहीं लिया. ओके. और इंडिया में तो भूल ही जाओ. या फिर अगर आपको ह्यूमिडिटी से फर्क ही नहीं पड़ता, वी डोंट केयर ह्यूमिडिटी. तो सिंपल, और कुछ इसमें नहीं है, ऐसा कोई साइंस नहीं है, रॉकेट साइंस. द सिंपल रीजन आई हैव एक्सप्लेन. करेक्ट. नाउ द क्वेश्चन दे कैन आस्क इन इंटरव्यूज, वर्किंग प्रिंसिपल ऑफ अ वेपर कंप्रेशन साइकिल एक्सप्लेन करो. इसके कंपोनेंट्स कौन कौन से होते हैं. यू नो 4 स्टेप्स. कार्नोट साइकिल पढ़ी होगी ना, 4 स्टेप्स. इन द सेम वे रेफ्रिजरेशन साइकिल 4 स्टेप्स. ठीक है. अब क्लॉसेस स्टेटमेंट का क्या सिग्निफिकेंस है in real life, I have explained all these things. Those applications of real refrigeration cycle and all, they are basically what? Significance of clauses statements. ठीक है. COP of refrigerator, COP of heat pump में क्या difference है? You guys already know that. ठीक है. Why is the throttling valve used? आपने पूछा भी था. I will explain. Don't worry. ठीक है. What does role does enthalpy drop play in determining cooling capacity? ठीक है. कुछ साइक्रोमेट्री या एसी रिलेटेड क्वेश्चंस, कि हमारा एसी, why does AC cool a closed room faster than the open room, even if both are of the same size? You have the idea. I have explained. What is sensible heat factor? We have explained. What is the air conditioner working in, how air conditioner works in the room? I have explained this. What is the effect on dry bulb temperature, wet bulb temperature, relative humidity, or sensible heat factor, or saturation humidity? You know that. ठीक है, तो ये सब चीजें आप आंसर कर सकते हो. ऐसे और भी क्वेश्चंस हैं, इंजीनियरिंग बेस्ड क्वेश्चंस हैं, like what is the role of refrigerant selection, you know, its impact and efficiency on the environment. ठीक है, how increasing evaporator area in the air conditioner or the airflow rate in the air conditioner increases the cooling effectiveness. ठीक है, यही वो पॉइंट हो गया कि आपके घर में जो एसी लगा है उसकी अगर आपको कूलिंग इफेक्टिवनेस इंक्रीज करनी है, क्या करना है? देखो, वो जो विंडो एसी होते हैं या स्प्लिट एसी होते हैं, उनमें आपको पता है एयर फिल्टर्स होते हैं. जैसे आप उसकी केसिंग ओपन करोगे, एयर फिल्टर दिखेगा, उस पर डस्ट पार्टिकल्स इकट्ठी होती है. वो डस्ट कहाँ से आई? आपके रूम से जो एयर थी उसी की डस्ट है, बाहर वाली एयर की डस्ट नहीं है. बाहर वाली एयर की डस्ट बाहर कंप्रेसर की साइड होगी, फ्रंट साइड नहीं. तो उसे आप क्लीन करो, डस्ट क्लीन करोगे तो यू नो व्हाट विल हैपन, एयर फ्लो विल बी इजी. और जितना एयर फ्लो इजी होगा, स्मूथ होगा, उतनी ही ज्यादा कूलिंग इफेक्टिवनेस इंक्रीज हो जाएगी. ठीक है. प्लस जो सर्विसिंग के लिए आप बुलाते हो कि भाई समर, अब नया समर आ गया, सीजन कंप्लीट, आओ भाई सर्विस कर दो एसी की. वो लोग आपसे 400 500 1000 2000 रुपए लेते हैं सर्विस करने के. किस बात के लेते हैं, क्या करते हैं? ये जो इवेपोरेटिव क्वाइल्स होती हैं, मैंने आपको दिखाई भी थी ना इमेज. कहाँ गई? ये, वो बेसिकली इन्हें क्लीन करते हैं वॉशिंग लिक्विड से या जेट की स्प्रे से. क्या करते हैं? क्लीन करते हैं, ताकि जो एक्सपोज्ड एरिया है वो क्लीन हो जाए एयर के लिए. एंड दैट्स हाउ द कूलिंग एफिशिएंसी विल इंक्रीज. रेफ्रिजरेटर फिर से चंगा हो गया. एंड दे चेक कि इफ देयर इज नो लीकेज इन द पाइप्स, दीज दो कॉपर ट्यूब्स आर देयर, इनमें कोई लीकेज वगैरह ना हो, क्योंकि लीकेज वगैरह होगा तो क्या होगा? गैस विल लीक, रेफ्रिजरेंट विल लीक. एंड रेफ्रिजरेंट लीक, फिर आगे भाई कूलिंग होगी कैसे? अंदर तो कुछ है ही नहीं फ्लूट करने, मूव करने के लिए. यू हैव, ओके. सो दैट्स हाउ यू कैन डू दीज स्मॉल स्मॉल चेंजेस, करेक्शंस. आप खुद भी एसी की सर्विस कर सकते हो, आपको वो 500 1000 देने की नीड नहीं है, इफ यू हैव द आइडिया. Why is the compressor the only component required external work in the cycle? Because और कहीं जरूरत ही नहीं है. In the compressor, we are increasing the pressure of vapor to increase the temperature. You know, the vapors coming from the evaporator, and we need to send them as high temperature vapors into the condenser. So we need to increase the temperature. That's why we need to compress them. And for compression, we need work. बाकी सब तो नेचुरल हो रहा है ना. हीट ट्रांसफर बिटवीन लो टेम्परेचर रीजन टू इवेपोरेटर, नेचुरल. हीट ट्रांसफर बिटवीन कंडेंसर टू हाई टेम्परेचर रीजन, नेचुरल. थ्रोटलिंग, सिंपल process है. It is just passing of a fluid through a narrow passage. We don't need any external work there. You know what is throttling process is. And so only compressor is there where we are doing some external stuff. We are increasing the pressure. That's why. Okay. Case study type questions. ठीक है. Imagine you are designing an AC system for a server room. What additional design considerations are involved compared to residential room, etc. And all that. तो जब आप डेटा सर्वर रूम की बात कर रहे हो, तो सर्वर रूम में जो कंपोनेंट्स है वो भी तो हीट रिलीज करते हैं. ऑल द इलेक्ट्रॉनिक डिवाइसेस डिसिपिएट द हीट, यू नो दैट. तो उन्हें भी तो कंट्रोल करना है. आप अपने रूम में पंखा एसी सब बंद कर दो, लैपटॉप ऑन करके चले जाओ, 1 घंटे बाद आके देखना रूम गर्म मिलेगा. क्यों? तो जादू हो गया. These electric devices is dissipating the electrical energy into heat energy. You know all that stuff. ठीक है. So that's all for the session, guys. I hope it was helpful to you. ठीक है. अब आपका जो डाउट था थ्रोटलिंग प्रोसेस, वो डिस्कस कर लेते हैं. एक बार मैं टाइम देख लूं क्या है. ऑलरेडी नहीं, चलो अभी है हमारे पास सफिशिएंट टाइम. ओके. Baki, for to get these PDF and all other discussions, if you want, either you can contact me through the WhatsApp, or otherwise you can connect to my Telegram channel. There you will get all the PDFs and everything related to these sessions. Okay. Just on the Telegram, search Gate with Ace. You will get the channel, my channel coming. Okay. Otherwise, you can find the link of that Telegram channel in the description. एंड आपका डाउट्स अपना वो भी क्लियर कर लेते हैं। उससे पहले एक पॉइंट बताना है सभी को, ठीक है? अनअकैडमी पे ऑफर चल रहा है, टुडे इज द लास्ट डे, टुमारो नहीं है, ये टुडे, आज के लिए। तो आपके जो भी फ्रेंड्स या कलीग्स गेट पीएसयूज की प्रिपरेशन के स्टार्ट करना चाहते हैं, तो यू कैन सजेस्ट देम कि न्यू बैचेस आर गोइंग ऑन। ऑलरेडी एक नया बैच हमारा लास्ट वीक मई के स्टार्टिंग 10th मई 11th मई से स्टार्ट हुआ है, और एक बैच हमारा इस मंथ के एंड में स्टार्ट हो रहा है। तो दे कैन गेट द 12 month सब्सक्रिप्शन इन जस्ट अ प्राइस ऑफ 9,999। 9,999 के प्राइस में उन्हें 12 months का सब्सक्रिप्शन मिल जाएगा। दे जस्ट नीड टू यूज माई एजुकेटर कोड, रेफरल कोड फॉर द डिस्काउंट एंड एवरीथिंग, ACE009। एंड आफ्टर यूजिंग दिस कोड दे जस्ट नीड टू इन्फॉर्म मी कि यस हमने कर लिया है, या फिर वो पहले भी इन्फॉर्म कर सकते हैं, ताकि मैं उन्हें गाइड कर दूं कि 12 months का लेना है, 9 months का लेना है, या 24 months का लेना है, 18 months का लेना है, कौन सा प्लान उनके लिए बेटर होगा, प्लस वाला या आइकॉनिक वाला, ठीक है? और उसके बाद मैं उन्हें वन ऑन वन गाइडेंस भी करूंगा, मेंटरिंग करूंगा, एंड हाउ दे शुड डू द थिंग्स एंड ऑल। ओके, अपार्ट फ्रॉम दैट टुडे इज वन स्कॉलरशिप टेस्ट, और यू कैन सजेस्ट देम। आज 11 AM वाला तो निकल गया, बट इवनिंग में 5 PM पे भी एक स्कॉलरशिप टेस्ट है ऑल इंडिया लेवल पे। तो हेयर यू विल गेट द चांस टू चेक योर सेल्फ वेयर यू स्टैंड among in national wise among all the candidates, plus the candidates who are not subscribed the other academy, they can get the 100% scholarship. Are you understand? 100% scholarship on the tuition fee they can get by giving this test. So this is one beautiful opportunity to get the subscription, और जो ऑलरेडी लो प्राइस पे है और लो प्राइस पे, सोचो, ठीक है? बाकी हमारा एक स्पेशल क्लास कार्निवल चल रहा है, जिसमें 23 to 25 में ही हमारी डिफरेंट डिफरेंट स्पेशल क्लासेस होंगी बाय डिफरेंट डिफरेंट एजुकेटर। यू कैन गो एंड चेक, दीज आर फ्री क्लासेस, एवरीवन कैन वॉच दीज क्लासेस, ठीक है? वहां आप अपने डाउट्स भी डिस्कस कर सकते हो, अपने पोल्स में पार्टिसिपेट कर सकते हो, और अपने एजुकेटर्स के साथ डायरेक्ट चैट भी कर सकते हो, रेज योर हैंड के थ्रू भी आप बात कर सकते हो, ओके, थ्रू वॉइस कॉल इन द लाइव क्लास। And the people who were the rankers in gate 25 and want to appear in the gate 26 again for a better rank, better opportunities, तो आपको additional discount मिल रहा है just because you are rankers, you can see, ठीक है? 28 मई से हमारा न्यू बैच स्टार्ट हो रहा है। दिस इज आवर टीम, यू कैन सी अंकुर बंसल सर, मी, देवेंद्र पुनिया, मनीष राजपूत, गुरुपाल चावला सर, अमन राज सर, मनीष सर एंड देवेंद्र पुनिया सर। और फ्लो में मैंने से सबका नाम लेने वाला, सॉरी, ठीक है? जिसमें मैकेनिकल ऑपरेशन स्टार्ट हो रहा है बाय पुनिया सर एट 8 PM। So this is something about the notification for UP. Now about your doubt, throttling process. The throttling process क्या है? Suppose we have a pipe, a fluid is flowing in this. Suppose if you put a orifice plate or a narrow restricted passage, in the tube, in the pipe. So you know when fluid will pass through this, what will happen? When fluid will pass through this narrow passage, you know, then there will be a sudden expansion, and due to the sudden expansion, what will happen? The pressure of the fluid will decrease. This is what we call throttling process. And here you can understand no moving parts, so no external work is done here. If you see the steady flow energy equation, so from steady flow energy equation, you can see where this is change in enthalpy, change in kinetic energy, change in potential energy. So here you guys can see ultimately the fluid will become fully developed again. So the velocity, because cross section area is same, so ultimately at the inlet and outlet the velocity will be same as well. Either you can say C1 C2 or V1 V2, ठीक है, यहाँ पे हम C1 C2 ले रहे हैं बिकॉज V1 V2 हम वॉल्यूम के लिए रहते हैं. सो टू अवॉइड एनी कंफ्यूजन, C1 C2 representing velocity. So it can be neglected. Potential energy can be neglected. As you can see, there is no elevation as such. Okay, there is no heat transfer. There is no heat transfer. There is no heat transfer between system and surrounding if it is perfectly insulated. Correct. No external work is there. No moving part. No shaft work. So this will be zero. So you can see ultimately m dot H2 minus H1 will be equal to 0. That means H2 is equal to H1. That's why it is what we call isenthalpic process. I hope it is clear. Okay, guys. So this is what throttling process. A basic idea. No moving parts, so no shaft work, insulated, so heat transfer. मेरी क्लास चल रही है. मेरी क्लास चल रही है. Okay. So sorry guys. So this is what you can say थ्रॉटलिंग प्रोसेस. अब इसमें आइसेंथेल्प पे वो जूल थॉमसन कोएफिशिएंट, इन्वर्जन कर्व, वो सारी चीजें, वो थोड़ा बड़ा डिस्कशन हो जाएगा. उसके लिए अगर आपको चाहिए होगा तो बता देना, हम एक सेपरेट सेशन ले लेंगे. वो आपका कुछ इस तरह से होता है जब आप टेम्परेचर वर्सेस प्रेशर का डायग्राम ड्रॉ करते हो फॉर डिफरेंट डिफरेंट आइसेंथेल्प्स. एंड दिस वाइट कर्व इज व्हाट वी कॉल इन्वर्जन कर्व. And Joule Thomson coefficient is nothing but the slope of this curve, that is dt upon dp at constant enthalpy. And these are the various isenthals. Okay, so where is the cooling region, where is the heating region, how all this happens, so that we will see in the throttling process. That is a totally separate discussion. तो प्लस पे मैंने क्रैश कोर्स में भी एक्सप्लेन किया है ऑलरेडी. जो थर्मो अभी कंप्लीट किया है लास्ट वीक, लास्ट मंथ ही, उसमें भी आप डिस्कशन में हम किया था, आप चेक कर सकते हो. अदरवाइज आप मुझे बता देना अगर आपके पास प्लस का सब्सक्रिप्शन है, तो आई विल शेयर द लिंक ऑफ दैट पर्टिकुलर क्लास, तो आप डायरेक्टली उसे चेक कर सकते हो. ओके. और अदरवाइज if you need, to mention in the comment box of the video, I will take a separate session on this. ठीक है, क्योंकि थोड़ा बड़ा डिस्कशन हो जाएगा और ये वीडियो ऑलरेडी हमारा काफी लंबा हो गया है. ज्यादा लंबा करने का मतलब नहीं है, और फिर हम एजेंडा जो हमारा वीडियो का था टॉपिक, उससे भी डेविएट हो जाएंगे. ओके. So that's all for the day, guys. I hope you have understood how the psychrometry affects, psychrometry changes, how you can move on, how the point changes on psychrometric chart in air conditioner, in air coolers, what is the working of air conditioner, air coolers, everything, refrigeration cycles, real life applications. So all these things are clear to you, and now you can answer all these type of questions. Okay. So still, if you find any difficulty, any doubt, either you can connect me on my Telegram channel, or otherwise you can WhatsApp me, call me, or you can come ask in the comment box of the video also. I will check and reply you. Okay, so that's all for the day. बाकी जो ऑफर वगैरह चल रहा है वो अपने फ्रेंड्स को बता देना. अगर उन्हें कोई डाउट है, कुछ पॉइंट जानने हैं कि अनअकैडमी क्यों ही ज्वाइन करना है, इन्होंने बोल दिया सिर्फ इसलिए, नो. आपकी स्पेशल क्लासेस का ऑफर चल रहा है अभी 23 to 25 में, जिसमें सभी एजुकेटर्स कुछ कुछ स्पेशल क्लासेस ले रहे हैं पर्टिकुलर टॉपिक्स पे. आप उन सेशंस को जाके चेक कर सकते हो. उसका लिंक भी, स्पेशल क्लासेस का, आपको लिंक डिस्क्रिप्शन में मिल जाएगा, जहां आप किसी भी एजुकेटर की वीडियोस क्लासेस का टाइमिंग देखकर वहां ज्वाइन कर सकते हो और उनसे डिस्कशन कर सकते हो, और आपको आइडिया लग जाएगा कि वाई अनअकैडमी. क्योंकि इन इंजीनियरिंग स्ट्रीम, इन एनी इंजीनियरिंग स्ट्रीम, स्पेशली केमिकल, द मोस्ट एक्सपीरियंस एजुकेशन एजुकेटर पैनल इज हियर ऑन अनअकैडमी. हमसे ज्यादा पुराना कोई नहीं है. ठीक है. दिस इज आवर टीम, यू हैव सीन. ओके. सो सी यू गाइस ऑन द बोर्ड. मिलते हैं. नेक्स्ट टॉपिक क्या होगा, आप लोग बताओ. नेक्स्ट टॉपिक आपको क्या चाहिए, कमेंट बॉक्स में बता देना. नेक्स्ट उसी टॉपिक के ऊपर वीडियो सेशन बना लेंगे, कोई इशू नहीं है. ओके. मैं, मेरा ऐसा कुछ डिसाइडेड नहीं है. मैं बस सुबह उठता हूँ, मन में जो टॉपिक आता है पहले मैं सुबह उठ के भगवान से बोलता हूँ, भगवान बताओ आज क्या टॉपिक कराऊं। वो जो टॉपिक मेरे माइंड में पहला आता है मैं उस पर वीडियो बनाता हूँ। मेरा ऐसा है। ठीक है। तो आप लोगों को जिस पर्टिकुलर टॉपिक पे चाहिए मैंने पहले ही बताया, फिर से बता रहा हूँ। कमेंट बॉक्स में मेंशन कर दिया करो या फिर व्हाट्सएप या टेलीग्राम पे आप मुझे मेंशन कर दो। मैं उन टॉपिक्स पे वीडियो बनाता रहूंगा। ओके। तो सी यू गाइस, मिलते हैं बाद में। टिल देन बाय बाय, टेक केयर, हैव अ ग्रेट डे अहेड। सायोनारा। एंड यस, अगर आपको ये सेशंस अच्छे लग रहे हैं, हेल्पफुल लग रहे हैं, तो प्लीज अपने फ्रेंड्स वगैरह के साथ शेयर कर देना और वीडियो को लाइक भी कर देना। ठीक है, ताकि उनकी भी